Yeah, hi Sohel.
Hi,
Yeah, let's start the interview.
sure.
Yeah, okay. I'll start with Python, okay?
Okay.
Yeah, okay. What is the custom exception?
Uh, yeah, wait a minute. Shall I share my screen first?
Yeah, please.
Uh, yeah, okay. Can you see my screen?
Yeah.
Uh, uh, okay. Let me open the video. Okay. Yeah. Can you ask me again?
Yeah. What is a custom exception?
So a exception is a user-defined exception class. That's basically inherited from Python built-in exception class. So it has a subclasses. So yeah, basically, this is where we use for the error handling. So it's more semantic and precise. Also, it's also give you a use of how to catch a specific error types rather than basically we get generic exceptions. So this will make us debugging easier.
Yeah, okay. Uh, how do you read and write a file in Python?
Sure. Do you need to write the code?
Yeah, yes, please. You can.
So there are for reading part we have the R part where like if I have let me uh, give you like yeah so it dot open this will the open file with here we will give any name like file dot any txt like something. Then if we want to read then we have R part. This will read the part whole file. Then whole file. So here we will give like content equal to file dot read. So it will read the whole file. If I want to read like loop wise each sentence line by line, so we also can do that. With open file txt dot r same for r for read. Then wait a minute, I think I will. Also here content file, but here we will add a loop like for line in file. Here we will like we will anything we can do like read something or write or strip basically print line dot strip. Here we can read the files with this quad. Here it will read as a whole string as a file. Here we will read a like each sentence.
Okay.
This is for the read part. Then if I want to write in Python, then we also can use like I will just write file dot write and I will write anything I want like that's it. It will write if I give slash n then it will start the sentence next sentence in the next line.
Yeah,
So this
okay.
is where yeah you can also like uh, I think append a file, like it's also writing. So same like with dot open file dot tsp. So here we use a part to append as append as a file.
Yeah, okay, that's okay.
So we will write. Okay, sure.
How does super work in internally?
Uh, what?
Super method.
So okay, super method. So super method returns a basically super method uses a MRO, basically method revolution order, to find the next class in the inheritance hierarchy. So this is what happens. So basically, super returns a proxy object that designates method calls to its parent class. That's what it. So
Yeah, okay.
basically, super dot initial. We can keep this method in the child class, then it will do the work.
Yeah, okay. Can you please give me some differences between threading and multiprocessing?
Sure. So likewise, how to say this? Like multi-threading and you said threading or multi-thread?
Threading and
Hello.
multiprocessing.
Multi-processing, right? Okay. So, mm, mm, okay. So in threading, I think the main difference would be has sorry, threading has same memory, where multiprocessing has separate memory for each multiprocessing. And also we have global interpreter lock, which is affects the what multi-thread threading part, whereas multiprocessing it doesn't affect. So uh, there also a overheading part where is threading has low and have high in the multiprocessing. So basically, multiprocessing is a CPU bound task, whereas threading is a IO input and IO bound task.
Yeah, okay. Can you please say some differences between like yield and return, where we can use those?
So yeah, yeah. So you want me to give you yield and
Yield and return.
so basically yield is something like when we do loop part. So it's just like a flying part. They give us the results like one, two, three, and so on. Whereas return is completely give us the output of that part.
Yeah, okay. What are generators?
Hmm?
What are generators?
Generator. Okay. So generators are something basically how to uh, mm, basically as I said before we use yield, right? He generators in that we use yield instead of return. So in this like generators they generate values on the fly uh, with saving memory.
Okay.
So if you want to write, I will write here something
Yeah, can
which
you
is
please give me an example for this?
so we have Fibonacci series, right? So I will create a function that Fibonacci. So here I write limit something anything. So here I will write a comma b. equal to 0 while a less than limit yield a. So here I will a be equal to b, a plus b. Then none in Fibonacci. Here I can write 10 something. I will write print. So run this part. So you can see here we create a Fibonacci series and it each time returns the result without fail.
Yeah, okay. Okay, now we'll move to NumPy.
Okay.
So, yeah, we'll move to NumPy and Pandas. So, can you
Uh,
please say me some differences between a view and a copy? What is a view and what is a copy?
uh, what?
What is a view and what is a copy? So, some differences between view and a copy.
Okay. So like views are like a new it just refers the part of basically view doesn't have a memory. So it's just like referring to the part uh, let me if I say view copy is basically we create a new array. So it has a new data, but the data is copied from like object A, variable A. If but view is something like it's just referring to the object A. So it doesn't have any data.
Okay. How it could
Mm,
manage the
mm.
memory, like how?
So I will give you example that will be like if I import numpy as np and I will create an array. Okay, array equal to np dot array something like 1 2 3 4 5. I so I create a view. So it just will be like array. I will slash uh, slice it. So this is a view.
Okay.
Basically, it will like chase data, but in the copy, uh, array 1:3 dot copy. So this is what happens if I change if I print the view, it will refer to the array, not like it will just give us what's the array part. Now copy is basically a different part from the other thing. So copy is referring to itself, not refer to the array part. So that's the difference between both things.
Yeah, okay.
So it will view doesn't store anything basically. It just refers to the array. Copy is storing the thing. That's the main part. It takes place, view doesn't take place.
Mm-hmm. Okay.
Hmm.
So, do you know some broadcasting rules are there, right?
Yeah, sure. So they are broadcasting basically allows operations between arrays of different shapes. So rules are we have like dimensions are compared from right to left, and also each dimension must be equal or one of them must be one. So that's what we do. And also, if there are missing dimensions, then they are treated as one.
Yeah, okay. Yeah, can you please show me this?
What?
How it will work?
Okay. if I have an array, mm, like we have yeah, okay. So we have array like b dot a equal to 3 comma 4 or 5. So this is an array. If if I do that like a plus 4, print a plus 4. So the result will be every element of the a will be added 4. So basically here we compare the dimensions from left to right, and each dimension must be equal. So the equal or one of them must be 1. So the another dimension will be 4, the single 4. So just single element. Okay, I don't think. 4. Okay. So see, each one of the following will be added 4 things. So 3 plus 4, 7, 4 plus 4, 8, 7. So so here we have something like each dimension must be equal. So every if I add like if I do like this, I create an again number different different dimensions like 4 2. So it will not work. So as you can see, we got see as you can see, we cannot broadcast together with shapes like 3 and 2. So we have here three elements and we have two. So we can't do that. Either it will be one or it should be equal dimensions.
Yeah, okay.
That's what.
Yeah, okay.
Yeah.
So we have NumPy, right? But why we need pandas when we have already NumPy exist?
Uh, Basically, NumPy is for statistical purposes, whereas pandas is for the table manipulation. So we do table manipulation in the data. Like we can group by, we can sort the array, and it also does what like it's very helpful in that part.
Yeah, okay. So how does group by work internally?
What?
How does group by work internally?
Oh, sure. Uh, so basically, group by what it does was there are 3 steps for it. So first, it will the split. So it will create group based on the key we have given. Then apply functions to each group. Then we have combine. So it will combine all the results. To each one. That's what.
Yeah, okay. So what is the role of the index in pandas?
So uh, indexing in Pandas, right?
Yeah.
Mm, so indexing we use uh, indexing in Pandas. How to? I think I will go next question. I don't know how to.
Yeah, sure. So what is a pandas data frame? How it works?
So Pandas data frame is like basically a table. Uh, Basically a collection of series of objects sharing the same index. So yeah, now I got what is index. It's basically index is basically a column name. Yeah, that's a column name or basically a category of data. That's what is index is. So in the data frame is a collection of series of objects saying having the same index. So internally, if you have 1D of arrays, then it will column, each column is a numpy array. So the index is a separate array for each of the data frame. So columns can have different types. So if we go through one row of the data frame, we can get many types of data in a single row.
Yeah, okay. Okay, fine. Let's move to project. So as we completed a project on like local AI chatbot and RAG chatbot, right?
Yeah, yeah,
So can you please
yeah,
open the RAG chatbot?
yeah, yeah. So
Yeah.
this is now.
Can you please explain the backend, what we have done in the backend? Sorry, what you have done in the
So
backend. So what is the purpose
yeah.
of it? How it will work?
So yeah, so we have the backend file. So this files implement the backend of RAG, which is retrieval augmented generation. So in this shortbot, it handles document loading, vector embedding, similarity search. We used files interaction with Gemini LLM and conversion precision. So we have imported the libraries of OS, WID, and JSON. So in this, we used OS used to interact with the operating system files like folders and also environment variables (EV). And also we use WID, which is basically generate unique conversation threads IDs, and also we use JSON, which is to store the chart history in the local JSON file. So these are the standard Python libraries used for the file handling, unique ID generation, and storing chart history. So we used the files part. Basically, files is used to fast vector search, and we also NumPy part. So as I said, is used for numerical operations to on embedding. So pairs help us efficiently to find most of the relevant documents by comparing the embedding. And we have the .env .env file. So it basically loads loads API keys from .env. And we have sentence transformers, basically converts text into vector embedding. And also we have chart generative Google Generative AI. So basically, we call Gemini LLM via LangChain. So we will load environment. Basically, this ensures the application falls early in the if the fails early if the API key is missing. So here we use JPI, which is in the .env file, and also next, we have the LLM part. So this in this part, basically what it does is we use the Gemini 2.5 slash with temperature zero, which is basically deterministic answer. So it doesn't give us a creative answer or guessing answer, like it create own things. So it will just give a factual answer. So there will be this ensures consistent and the factual responses. Also, we have local DB part. So this first one will be the DB file which stores the chart history, and then we have files index file. So this stores the files index part, and we have the source doc folder documents, which our documents we use for the chunk part. And also here we have conversation storage functions. So each conversation is tracked using the thread ID, so multiple charts can be maintained. Uh, then we have the embedding model, which we used was, as I said, in the importers part. So this an all meaning this algorithm. So this part basically this model balances speed and semantic accuracy. Then we load the documents using this function. Basically, this in this part we read all the text from the documents and store documents text and meta file. So this will be the documents from the base for the rack system. Then we have the phase index creation. Here we
So,
create the phase index part.
so here,
What?
so here, what
Yeah.
is the docs and metadata?
So uh, uh, I, docs are like the file names. We turn into chunks, right? So each one will be get a title. So it will be easy to search. And metadata is the actual data of that file.
Yeah, okay.
So
Yeah,
then we
continue.
have the files index. Yeah. Then we have files index generation. So this will convert documents into embeddings part. So here we encode the part, then we create index using the L2 distance, and we store the index on disk. So this phase allows like extremely fast similarity search, even for the large document set. So that's what this do. Then we have the load files index. So this avoids the recomputing embedding every time the app starts to restart. So this will like if we already done this part, so this will be like no second time. It will always load the previous loading part. Then we have like documents, basically documents retrieval here. Yeah. So in this part, we retrieve retrieval part of the RAG. So here we take the top documents in the similarity set. So then we have the chart track. So basically, in this chart box, we basically retrieve relevant documents, combine them into context, and create a structured prompt to ask Gemini, and then we save conversation. So this is the whole part of the rack. Yeah, this is the backend file of the whole rack.
Yeah, okay. So can you please open the front end file?
Front end part. So
Yeah. So
so
just explain me
basically, the
overall
front.
what will happen here.
Yeah, sure. I will just go. Yeah. So, but basically, what happens is this file implement the Streamlit UI for the rack chatbot, including chart history, multi-threading conversations, and real-time interaction. So we input Streamlit for the front-end framework, and also we import the backend functions from the backend. So we check the thread ID. Basically, I will give you Sean. This reruns the script, so session starts is essential. So that's what it do. Then also we have sidebars, sidebar basically which has the chart threads like conversations, and we can import the new chart for the next new chart. This behave like Chat GPT multi-chart system, and also we have if we want to switch the threads between each other, we can do that. Then also we have the chart history part. Then user and assistant assistant messages are usually separated. And also we have chart input. So this creates a real-time conversation experience. Basically, display users message, call backend rack, and display AI response. This is what it does. This target.
Yeah, okay. So is it possible to you to run it?
Uh, okay. I need to first. I need to activate. Okay. Then I will run the plot. Okay. Hmm. Can you see my screen?
Yeah.
Yeah, it will take 2 minutes, I think.
So can you please tell me some differences between like normal chatbot and RAG?
So LLMs are basically trained on so much data in the real world. So basically, but it's not updated. Basically, it will be lag behind the information each time. So it will be updated like a year before or a couple of years before. So as you can see here is the RAG part. So yeah. So in the normal part, it will have be like if it doesn't have the information, it will guess and give us the wrong answer. Basically, it's hallucinate and give us the wrong answer, which is will be the wrong information. So as for the rack system, it will give only to related documents which we have provided. So if the company uses the chatbot, it will have like policies, documents, agreements between the companies and many things like user agreements. So if we ask to the RAG chatbot, it will give us like no hallucination, no guessing. It will give the real-time answer and the perfect answer, which is currently present in the company. So it will not give the generic answers. Yeah.
Okay. So is there any chance of hallucination in this RAG? Why? Because
No.
normal LLMs can give us the answer in by
Yeah.
hallucinating. So is there
Yeah.
any chance here?
Yeah. Yeah. No. No.
No.
So if I ask something like see, tell me if I ask something like disadvantage, it doesn't have that argument for that part. So it will be based on the provided documents. There is no information. So it will not basically guess and give us the answer.
So I think it may be give answer by hallucinating. Why? Because if we don't provide any sufficient information, so by that time
I'm
it
saying
will
about the RAG.
hallucinate. Yeah.
Are you saying about the RAG?
Yeah.
Okay.
Right only. So
Okay.
by lack of information or by insufficient information, it may be chance to give answer by
Oh,
hallucination.
oh.
Yeah, okay. So why you prefer only Streamlit for the front end?
So basically, Streamlit has its like basically we don't need to have the frameworks of different types. Basically, if I use CSS, HTML, JavaScript, then it has its own framework. But Streamlit has its easy because we can call the endpoints. Also, there is a visuals thing which is easy to use in the chatbot. That's why I use.
Yeah, okay. What are the requirements you have taken for this?
Hmm?
What are the requirements you have taken for to do this project?
So basically, I created a just a simple RAG chartboard. So this is for the testing part. So here we give the some test and we preview it. And this is just basically like testing the RAG for the learning purposes. Uh, Uh, as per the requirements, I basically, as I said before, I use the phase and sentence transformer for the embedding part, phase for the vector storage. and I use the free generative AI Gemini part. So it's free, so I use that part. And also for the storage, I use basically local storage, JSON formats, and also I use Streamlit for the front end part.
Yeah, okay. So, which one is fast? Is a normal LLM chatbot or a RAG chatbot? Which will give us a like, which is in fast mode?
Yeah, I think it's that
Yeah, okay.
because basically RAG has its documented documents already, so it doesn't need to guess. It doesn't need to guess something. So, but in the law, LLMs basically has large information, and it has so it need to search for them and also basically comprehends each thing what user asks or what it should be give, and also it need to guess and generate things. So it's RAG is faster than that.
Yeah, okay. So, mm, so is the normal LLM chatbot has like some organizations data is there, right? So it will give us some answers from those.
Yeah, the documents which we provide will be given the drag chart we will give the answers. If we don't provide the documents like internal documents or we don't want to show to the public, it will not be because we didn't provide the documents to that act of that part, so it will not be the answers which are security purpose.
Yeah, okay, thank you. Yeah, that's all from my side.
Yeah, thank you.
Thank you.